So this is lesson 2.6 in elementary algebra, and we'll call it 2.6a. The way we've been going, we've been doing a lot of multiple videos here. So 2.6a, and the name of this section is called applications, which is a very nice way of just saying story problems. So this is a section dealing with story problems that have a certain strategy in order to figure them out. And there's 4 different types of story problems we're going to do here. We're going to do number problems, age problems, geometry problems, and coin problems. We'll just start these one step at a time. Now, if you want to do the how-to steps on bottom of page 141, that's fine. And I kind of real loosely follow these steps as we go, but I'm not a real strong adherence to those steps if I can find an easier way to do these. All right, so the first thing we're going to do, look at example 1. We're looking at the first sentence, and I like to look at the first sentence of even the longer story problems because it usually just kind of gives you an idea of what's going on here a little bit better. And this first sentence says the sum of twice a number and 3 is 7. All right, so what we're doing is we're looking for, first of all, the variable, the unknown. What do we know the least about in the story problem? Well, the sum, that's the answer to a plus problem, so I kind of know something about that. Twice a number, I know something about twice, and 3 is 7. But the number, the word number, is what I know the least about. I know nothing about what that number is. So that ends up being what I'm looking for. So let's look at what it says here. The sum of twice a number. Twice a number means 2 times a number. And again, we said the number is our unknown. That's what we don't know. The sum of twice a number and, so we've got something else we're adding to twice a number, and 3, and then you see that is again, that is means equals. And there's your equation. And you solve it from there. So again, you subtract 3 from both sides, and you get 2x equals 4. And you divide by 2, cancel, x is equal to 2. And then we take our answer, and we plug it back in there. 2 times 2 is 4, plus 3, yes, it is 7. All right, so there are going to be some problems that you can do without algebra. You could have probably figured that out. Twice some number plus 3 is 7. But you've got to get used to practicing the algebra part of it because it will make your life easier in the long run. All right, let's look at example 2. One number is 3 more than twice another. Okay? Their sum is 18. All right, so the last sentence says find the numbers. So we're talking about 2 numbers, and this is very important when it comes to these story problems. Make sure you're giving me the answer that you're supposed to, because sometimes a student will just give me, oh, I found x is 5. But it says find the numbers, plural. There's 2 numbers we're talking about. One number is 3 more than twice another. Okay? So one number is 3 more than twice a number. How are we going to write that? The biggest problem with this is I don't like how they wrote this because it makes you think that you have 2 variables here and you really don't. So one number, we know nothing about it, so we'll call it x. So that's our one number, or our first number, is 3 more than twice another. Okay, so this number here is 3 more than twice another. Okay, 3 more than twice another. Okay, and it also says it is one number is 3 more than twice the other. It also says that if you add both of these numbers together, you get 18. Okay, so our first number is x, our second number is 2x plus 3. Okay, so we have, I don't know why I have that, 3x plus 3 equals 18. Subtract 3, and we get 3x equals 15, and we get x equals 5. So that's one of our numbers. Now remember, we're looking for another number. We have this as one of our numbers, this is our other one. So our second number is 2 times 5 plus 3. So one of our numbers is 13, and one of our numbers is 5. And that's pretty much as hard as the number problems are going to go. The age problems, one of the things that's really important when you're doing age problems is the whole idea of charts. Okay, so let's look at this first one, example 3. We have Bill and we have Tom. All right, what do we know about Bill and Tom? Bill is 6 years older than Tom. Who do we know the least about? We know the least about Tom, right? So we'll give Tom the x, and Bill is 6 years older. Okay, so right now, Tom is x, and Bill is x plus 6. 3 years ago, what do we know? It says 3 years ago, Bill's age was 4 times Tom's age. Okay, so how old was Tom 3 years ago? Well, if he's 10 now, how old was he 3 years ago? 7. Okay, I'm just making up numbers. If he's 12 now, he was 9 3 years ago. So whatever age he is, he was x minus 3. He was 3 years younger. Okay, how old was Bill 3 years ago? Well, if he's x plus 6 now, then 3 years ago he was x plus 6 minus 3 years, because it's 3 years ago. So I'm going to change what that looks like and write it as x plus 3, because 6 minus 3 is a 3 there. So rather than write all those numbers there, it's just easier to write x plus 3 there for his age 3 years ago. All right, so our chart is filled in. So it says 3 years ago, Bill's age was 4 times Tom's age. Bill's age 3 years ago was 4 times Tom's age. So without that 4, we'd be saying that Bill's age and Tom's age were the same 3 years ago, but what it says is Bill's age was 4 times Tom's age. Well, so if his age is 4 times Tom's age, in order to make them equal, we have to put a 4 on Tom's age. Because remember, what you do to this side, you do to this side. Over here we said this age was 4 times this age, so in order to make them equal, we have to make this one 4 times. Okay? Many times people will put the 4 over here. But make sure you look. You're trying to make their ages equal. In order to make them equal, you have to make Tom's age 4 times. All right, then we can do distributive. Okay, we're going to get the smaller x over here. Remember what I said. You try to do that. The smallest variable you try to move first. So you have 3 equals 4x minus 1x is 3x minus 12. Add 12 to both sides. And we get 15 equals 3x. That goes away. Divide by 3. Divide by 3. That goes away. 15 over 3. X equals 5. So, Tom's age is x. So Tom's age is 5. What's Bill's age? Whatever x is plus 6. So Bill's age is 11. So you would specify Tom is 5 and Bill is 11. Just so we're specific on who's who. Alright, so this table is really, really important. It really will make life easier for you as you're trying to solve these by having a table like that. And I do not expect you to get these real easy. Nobody really ever gets story problems first time. Some people struggle all of their lives with story problems. That's okay. It's just getting yourself to where you're thinking logically and being able to do these as best you can. All right, so let's look at a geometry problem, and then we'll go on to a new video and continue on with the coin problems. Okay, so the length of a rectangle, and again, drawing these pictures really does help me get what I'm doing. The length of a triangle is 5 inches more than twice the width. What do we know the least about? We know nothing about the width, but what do we know about the length? It's 5 more than twice the width. Okay? All right, the perimeter is 34, and they want us to find the length and the width. So we're looking for this distance and that distance. All right, so we know there's a formula for perimeter. 2 times the width plus 2 times the length. Well, let's use that formula. Perimeter is 34, so we can plug a 34 in for P. How wide is it? It's x wide. How long is it? 2x plus 5. So all I did was replace the w, the width here, with an x, and the length with the 2x plus 5. So you see how it helps to have that little drawing there? So 34 equals 2x plus 4x plus 10. Distribute that 2. All right, 34 equals 6x plus 10. And we need to get rid of everything around that doggone x there, because that goes away. And then we divide by 6, and 4 equals x. All right, now again, is that what I'm looking for? Am I looking for x? That's not all I'm looking for. What is x? X is the width, but what's the length? 2 times x plus 5. So 8 plus 5 is going to be 13. So the length is 13, and the width, we said, is 4. Okay? So next video we're going to do coin problems, and then we'll do some practice problems from the lesson.